Good morning, Algebra 2 students. This is Ms. Myers here. We are going to finish up lessons 4 through 7, day 2 here today. I hope you understood what I went through with you in day 1. This follows very, very similarly from this, okay? So we want to remember a couple basic things here. One is that when we are dealing with a right triangle, that we get to use our lovely 9-letter acronym of SOHCAHTOA. So I was drawing the triangle for you as a reference. Notice I place an angle theta as one of the non-right angles, and from there I label opposite and adjacent, and then of course the hypotenuse is always crossing the right angle. So the sign is opposite over hypotenuse. And we've got ourselves cosine, which is adjacent over hypotenuse. And then of course we have ourselves tangent, which is opposite over adjacent. Now something else we want to remember are the 3 reciprocal trig functions. So cosecant is the reciprocal of sine. So since cosecant theta is the reciprocal of sine, then that means cosecant is the hypotenuse over the opposite ratio. Then we've got ourselves our secant function, which is the reciprocal of our cosine. And since cosine is adjacent over hypotenuse, that means secant would be hypotenuse over adjacent. And lastly, we have our cotangent function, okay, which is the reciprocal of tangent. And since tangent's opposite over adjacent, that means cotangent is adjacent over opposite. All right, so we've got 2 problems to go through today. The first one says, if the terminal side of angle theta it passes through, and you're going to get a coordinate of a point here. It passes through, and I'm going to give you the coordinate -6, 10. Oops, sorry, I mean 6, -10. What are the 6 trig function values of theta? All right, so let's make a nice little sketch here. Okay, and we're going to plot the point 6, -10. So let's say about here. Okay, so this is the point 6, -10. So we're going to do again what we did in lessons 4 to 7 day 1, which is we're going to make a right triangle. Now it does matter how you make that right triangle. It's always going to be such that you have a perpendicular to the x-axis, okay, not to the y-axis. Reason being is because you want to have your reference angle be part of the triangle there, okay? So if I tell you that the terminal side of angle theta passes through this point right here, so this angle, if I think I rotate, if we're going to rotate around counterclockwise from standard position, okay, here's initial side on the positive x-axis, rotating around to here's terminal side of my angle passing through this point 6, -10. So if this is angle theta, this would be the reference angle for it, right? And hopefully you've caught on now that really if I want to find any trig function value of theta, I really just have to find the trig function value of the reference angle alpha for that, and they will be one and the same values, okay? So when I plot this point 6, -10, what I did is I went to the right 6 and I went down 10. So for this right triangle, I now know that this horizontal leg is 6 units, and I know that this vertical leg is 10 units. So if I want to find out what are the 6 trig function values of theta, I really want to just know what are the 6 trig function values of alpha, and I can answer the question. So that means I'm going to use the lovely 9-letter acronym SOHCAHTOA. But as soon as I go to state the sine value for angle theta, which is really just what's the sine of angle alpha here in this triangle, right away I have opposite, which is 10, but what is my hypotenuse, right? So how I'm going to get that is I'm going to use Pythagorean theorem. All right, Pythagorean theorem always allows us to take any 2 sides of a right triangle and find the third side. right? Leg squared plus leg squared equals hypotenuse squared. So my two legs are 6 and 10, but I don't know my hypotenuse. Let's just call that C. So 36 and 100. Make sure you add those together to be 136. Then you square root, and let's just see if we can simplify 136. So does any perfect square divide into 136? That we can simplify it because it's not a perfect square itself, and it turns out that 4 does. Okay, if we do 4 times 34, we will get 136. Okay, so that means square root of 4, square root of 34, right? That product right there is 136. So this is now 2 squared 34 is our length of C, our hypotenuse. All right, so we're going to rationalize that denominator, multiply by square root of 34 over square root of 34. So now we get 100 square root of 34 all over. So this is going to be 2 times 34 or 68. But now I want to reduce that down. All right, so I know 2 divides in there. So that's 50 square root of 34 over 34. Actually, I could have reduced by 4, by another 2 here now. So it's, let's say, 25 square root of 34 all over 17. I think that's as good as we're going to get. But there's one more thing we want to think about, okay? We're in quadrant 4. So should that sign value be positive or negative? So let's just recall that in quadrant 4, okay, only the cosine function is positive. So we need a negative there. Okay, so this is a negative 25 square root of 34 over 17. Okay, so how about the cosine value? So cosine is adjacent over hypotenuse, right? So I know the adjacent was 6. Hypotenuse 2 square root of 34. Again, rationalize that denominator. Okay, so 6 square root of 34 all over the 68. Okay, 2 divides into both those at the same time. So now you got 3 square root of 34 all over 34, and that is it. And again, think about what quadrant we're in and what functions are positive and negative in that quadrant. And so cosine's positive, so there we go, leave it just like that. So moving on to tangent. Okay, tangent's opposite over adjacent. So that's just your 10 over your 6. And that reduces down to 5/3. Again, negative though, because we're in the 4th quadrant, right? So tangent's negative. And now we do our reciprocals, okay? So cosecant theta is the reciprocal of sine. So really, I'm just going to take this first value right here. I'm not going to go to the end where my radical's already in the numerator because I've got to reciprocate this, right? So I'm just going to go right from the very beginning where I had opposite over hypotenuse and then just do hypotenuse over opposite because now, see, radical's in the numerator and I'm good to go. 2 divides into 10 5 times, and that's it. Of course, that's negative though. Secant theta, secant's the reciprocal of cosine. Again, don't go to the final answer and reciprocate that. Go to this original fraction here where the denominator had that radical in it because this was adjacent over hypotenuse, and secant's going to be hypotenuse over adjacent. So I'm going to get 2 square root of 34 over 6. Divide out the 2 into the 6 3 times, and that's positive because cosine is positive. And then the last one is cotan theta. Okay, cotan being the reciprocal of tangent, tangent being 10 over 6, opposite over adjacent. Now this is adjacent over opposite, so 6 over 10, which is 3/5. And again, since that was negative, this is also negative. Okay, so that's our first of 2 problems. Hopefully that seems okay for you. One more, okay, so this is going to be along the same line, a little bit different though. So I'm going to now talk about a circle having a radius of 6 units. Okay, so let's call it circle O. So circle O has a radius of 6 units. Okay, an angle with a measure of pi over 3 radians. Okay, is in standard position. If the terminal side of the angle intersects the circle at point A, so if the terminal side of this angle intersects the circle at point A, what are the coordinates of point A? All right, so kind of similar to what we just did, a little bit different though, also taking into account what we've been doing for the last couple days. So we're going to put a bunch of the different things together. So of course, let's make ourselves a nice little sketch here. Okay, so we've got a circle of 6 units here in radius length. Let's get our circle. Okay, that's circle O. And we've got an angle of pi/3 radians in standard position. So that's going to give us an angle that looks like this. Okay, so this would be pi/3 radians. And it's intersecting this circle of radius 6 right here, okay, at point A. And we want to find that coordinate. Like, so what is that x comma y, right? So as we just did with the previous example, if we drop a perpendicular to the x-axis, okay, always the x-axis, that way this is in reference angle position, although it's the same as the given angle because it's a quadrant 1. If I want to find the coordinates of this point x, y, I really want to just know, like, what is this horizontal leg x in units, and what is this vertical leg y in units, right? Because to plot this point x comma y means, you know, you can go horizontally first and you're going to go vertically. And what I know in this triangle, this right triangle here, is that the hypotenuse is 6 units. Reason I know that is because the circle is 6 units of radius length, right? And isn't this right here the radius of the circle? That just coincides with the hypotenuse of the right triangle. So let's blow that right triangle up a whole lot, okay? Let's make it a lot easier to work with here. Okay, so I'm trying to find this x and this y. I know that this is 6, and I know that this is pi/3, right? So what I already know is the sine and the cosine values of pi/3 radians, okay? And if I use cosine of pi/3 radians, okay, so I know what that is. I know that's exactly a 1/2 value, okay? The cosine ratio in any right triangle, as we just talked about, is adjacent over hypotenuse. Well, here's the adjacent, which is x. Here's the hypotenuse, which is 6. And that has to equal 1/2. So then I just cross multiply, 2x equals 6. Divide out the 2, and x is equal to 3. And if I use the sine value of pi/3, okay, which I know is square root of 3/2, well, in any right triangle, the sine ratio is opposite over hypotenuse, which is y/6. And then I just cross multiply and solve that. So 2y equals 6 radical 3. Divide out the 2, and then that is y equals 3 radical 3. So if I know that this is a length of 3, and this is a length of 3 radical 3, well, remember what I was trying to find is this point A right here, x comma y. So now I know that that is 3 comma 3 radical 3. And that is my answer. All right, so I hope you understood both those problems that followed up from lessons 4 through 7, okay, day 1, and previous material in this module. So you got a few problems to try for homework for this, and of course, as always, post your answers by the end of the day, and then tomorrow I will post an answer key and you can check them over. Just so that you know, on Thursday, I'm going to post a review for Castle Learning on everything that we've been doing since Mod 4, Marking Period 4 started here in this module. So if you're having any issues, problems with anything, maybe you'd like to come and join the Google Meet on Wednesday and see what kind of questions you can ask, okay? Hope everyone is doing well.